Hey, you guys want to hang out after school today?
Yeah, I can hang out.
Nice.
I can't after like 5, but I have a doctor's appointment right after school.
What? Why? What's wrong?
I have a checkup.
A checkup? What's a checkup?
It's when you go every year and you get like shots and stuff.
Once a year, just to make sure you're alright.
You go every year since you're like 4.
I haven't been to the doctors for like 10 years.
How do you, like, function in society?
How'd you get this far?
Nothing's wrong with me. I'm okay.
Well, how do you know? You haven't been to the doctors in 10 years.
You're right.
You should probably get on that, if I'm going to be honest.
Picks it up in the offensive end. Point blank chance, and he's denied.
Yo, dude, what'd you get on that chem test earlier today?
You're like a 95.
Nice, dude. What'd you do wrong?
It said hydrogen bonding is an actual bond.
Oh, yeah, that'll get you. Yo, dude, you know what we haven't done in a while?
Huh.
We should prank Matt.
It has been a while.
Dude, it's been a while.
Dude,
And you know
April
what?
Fool's Day is coming up too.
It's perfect time.
That
It's
is perfect.
time. Wait, dude, what were we talking about earlier today with him?
The doctor's appointment goof.
Oh yeah, he doesn't do regular checkups. We could totally use
We
that.
definitely use
We could
that.
totally use that. Your dad's a doctor, right?
Yeah, we could use his office.
It's perfect. So we get him there. We're like, all right, you need to have a checkup. You haven't had a checkup in what, 10 years? Okay. We get him there. Your dad is in on it, right?
Right.
He's there with the lab coat on. You know, he's doing tests and stuff. He goes back. He's like, all right, I got some bad news for you, Matt. You have a mental deficiency.
Okay.
We convince Matt he has a mental deficiency.
Okay. My dad'd be in on that for sure. Deacon Senior would love that.
Nice. All right. Looks like we got a plan. Matt's getting pranked. Man, dude, that chem test was so hard today.
I just couldn't concentrate on the sound of it.
Yeah, I kept looking at Kevin's bald head.
Yeah. Alright, what do you... Been to the doctors yet, dude?
No, what?
Remember we had this discussion yesterday?
We
with
talked
the,
about this.
What? I'm not gonna get a checkup. What do you mean? I'm still alive.
You could be
I'm fine.
dying.
Dude,
We don't know.
We don't know. Like, you can have some
Those
kind of
chemicals in our lab
terminal
are dangerous.
Here,
Dude, it's
just
chemistry.
go to my doctor.
I'll be
alright?
fine.
Here's the address. Okay. Take one of these with you.
All right. Okay, well,
Alright.
I'll go.
Matt, ready? Dr. Goob is ready for you now.
Perfect. Matt, ready?
Good.
Right this way. Step into this room right here. Alright, so nice to meet you.
How's it going?
What brings you in here today?
I'm just going for a checkup, you know.
Okay, when's the last time you've seen us?
I've never been to the doctors before.
Alright, let's run some tests.
All right.
Yep, that's the uvula. Alright, so the last test we're gonna run is an IQ test. There you go, just call me whenever you're done.
Good. Thanks. Finished.
Alright, I'll be right back. I'll check the results and let you know how you did.
Alright, thanks.
Alright, well, when I crunch the numbers, you have an IQ of 63.
So what does that mean?
You have a slight mental deficiency.
I have a metal deficiency?
Yes, a mental deficiency.
I need Cameron. Help.
What do you need help with?
I have a solution of aluminum phosphate, and I need to make sure it has more aluminum in it.
Okay, what's your plan?
I was going to add aluminum nitrate into the solution, but I can't have it precipitate.
Why?
Because I'll be drinking solid aluminum.
Why are you doing it in the first place?
My doctor prescribed it to me. I went for a checkup, okay? Alright, I did it. So,
Alright, I guess we'll help you then.
okay, sweet.
So here what I'm going to do is I'm going to write out my equilibrium equation. You got your aluminum phosphate. Then I'm going to write out my KSP expression based on concentration products over reactants. And you'll notice I didn't include aluminum phosphate. Then I write my start change equilibrium. Then I write my KSP expression based on X, take the square root, and you can get your initial concentration for both ions. Now we want the QSP if 0.1 molar silver nitrate's added. Do the same thing, fill out your start change equilibrium with 0.1 as the initial. Then you solve for QSP using the initial concentrations you solved for above, and you get that QSP is greater than KSP, which means there's more products than in equilibrium. So your equation is going to shift left, yielding a precipitate. This illustrates Le Chatelier's common ion effect. Because there were already aluminum ions in solution, it made it more likely for aluminum phosphate to precipitate out.
I guess I'm just going to settle for less aluminum. Alright, man, well, I gotta go. I'm just gonna drink the rest of the aluminum phosphate in my house because, you know, I ruined everything I had here, so. Yeah, I gotta go meet Mr. Kemmer. We're fishing at noon, so.
Dude, it's like 3 a.m. and our project's due tomorrow. How can you leave?
Aw, man, I'm late. We'll film the project tomorrow, though. Alright, we'll film it tomorrow. We got time. It's fine. Oh no, my metal deficiency. Guys. Yo, I need help. Okay, I need to dissolve a zinc hydroxide tablet. What?
How'd you get in my house?
Doesn't matter. I came in from the window. It's fine. Look, I need to dissolve a zinc hydroxide tablet in a basic solution. I need help. Help me.
Let's go.
Let's do it. Okay, I'm gonna drop this in there. I expect it to not precipitate because it has a small concentration.
Alright, here we go.
Why did it turn blue?
Well, that, my friend, is a precipitate.
Well, what pH is your solution?
I don't know. Let's use this large piece of litmus paper to find out.
Where did you even get that?
Walmart.
Alright, solid.
It was on sale.
Huh, look at that. It turns slightly blue. That means you got a little basic solution there, dude. You don't want that.
Why does it matter this was basic?
Okay, we're again going to start with our equilibrium equation. Do the start change equilibrium, write it out, but this time we can find our initial concentration of hydroxide ions based on pH. As you see, we can use the log properties to get that the concentration equals 0.01. Then we sub this into our start change equilibrium, and then we can put the expressions into our KSP expression. And then we can solve for X. X turns out to be 1.96 times 10 to the negative 6 molarity. Then we can use this in our QSP equation in order to compare it with KSP to determine whether or not a precipitate will form. Using the math shown, it can be found that the QSP for this specific situation is greater than the KSP, and for this reason a precipitate of zinc hydroxide forms. Since the solution was basic, there was already a presence of hydroxide ions. This made it more likely for zinc hydroxide to precipitate. Had it been an acidic solution, the hydronium would have neutralized some of the hydroxide, making it less likely to precipitate.
See what's going on?
What's up, man?
Why's your water green?
I'm just drinking some nickels.
Nickels?
Yeah, how'd you get those in there?
Just nickels, pocket change. Been dissolving it in here for a little bit, and then you let it sit for like 20 minutes, and then
You know nickels are like 75% copper.
How did you get them to dissolve?
just let it sit for a while. Wait, they're 75% copper.
Yeah, you don't want that. That's a lot of copper.
How do I get it out, Cameron?
Well, we actually have a way to fix that.
Hey.
All right, Dan, you explain it to him. I'll provide the background.
Alright, okay. So, when two ions are in solution, the same solution, there's little that can be done to separate them. However, using a special procedure called titration, one could hypothetically precipitate most of one of the two ions out. Using this technique, we can precipitate the copper out, leaving only the nickel.
Alright.
This time we're only given grams per liter solubility of copper sulfide. Luckily, we can get KSP using our equilibrium expression and start-change equilibrium charts. See in here, you can convert from grams per liter to moles per liter using molar mass. Now we know the concentration of both ions. We can sub this into our KSP expression and square it to get KSP. Now we know KSP of both copper sulfide and nickel sulfide. We can compare these in our initial solution that's being titrated. This molarity that I'm calculating is where copper sulfide begins to precipitate. But we want as much copper sulfide as we can to precipitate out, so we're going to sub in the molarity of sulfide ions for which nickel sulfide begins to precipitate. Once we figure this out, we can work backwards using our concentration of given sulfide ions to get the volume that we need to add. This can be seen using this accurate representation of said titration.
We'll see who's metal deficient now. Let's go get retested.
Dr. Grubb, how you doing?
I'm good, how are you?
You know what? I came here to talk to you for a little bit.
I think I fixed my metal deficiency.
Your metal deficiency?
Yeah. My metal deficiency.
I don't think you ever had a metal deficiency.
That's what you told me last time, and guess what? You got some friends, we fixed it. So,
How did you do that?
I drank metals. Yep.
Alright, you need to pump your stomach right now.
We need to do this quickly.
Why? Why?
What metals did you swallow?
A lot of them. Why?
They're hazardous.
They weren't solids. I used the KFC equation.
Alright, well, the stomach pumping didn't work. Which means there's only one thing left that can save you. Gatorade.
But Mr. Kemmer said it's just salty Kool-Aid.
As silver adds on, we can get different ions to precipitate. Which one's going to precipitate first? The one with the lower KSP, the one with the higher KSP will precipitate out second.
Hey, you guys running out after school today?
Right now,
I can't. I have a doctor's
zero
appointment.
up until this number.